Okay, so what we're talking about today is Pascal's triangle, and we're going to be using Pascal's triangle to expand binomials. So the first thing we need to do is we need to fill this in and know what a Pascal's triangle is. So we start with 1, and actually all the numbers on the sides going down are all 1. Now the way you find this number here, I'm going to kind of cover it up, this number is made up of the 2 numbers above it. So 1 plus 1 is 2. I do the same thing here. This number is made up of the 2 numbers above it. So the 2 numbers above this are 1 and 2, so this is 3. And same thing here. This one's made up of the 2 numbers above it. 1 plus 2 is 3. And then we continue this pattern. This one is made up of 1 plus 3, which is 4. The center one is made up of 3 plus 3, which is 6. And then this next one is 1 plus 3, which is 4. Okay, so go ahead and see if you could fill in Pascal's triangle the rest of the way. Okay, so hopefully you notice some patterns. One pattern you should recognize is the numbers going down, and then the numbers going down on this side. That's going to be helpful because what we're going to see is that these rows highlight something to a certain degree, a binomial raised to a certain degree. Any binomial raised to the 0 power, you get a coefficient of 1, because anything raised to the 0 power is just 1. If I raise any binomial to the first power, it's just those binomials again. This one is binomials to the second power, binomials to the third, to the fourth, and so on. Okay. Now, one thing that I'd like you to recognize is when I have 0 binomial, or raised to the 0 power, I have 1 term. Okay. When I have something to the second power, I have 3 terms. To the third power, I have 4 terms. The other thing I'd like you to recognize is that when I raise it to the second power, the next number is 2. When I raise it to the third power, the second number is 3. Fourth power, the second number is 4. So those are both things that will be helpful for you. Okay, so when you expand, there's a process we need to do. The first thing is we need to determine the row and the triangle and write the coefficients. Then we're going to write the first term from left to right with descending powers. Then we're going to write the second term going from right to left this time in descending powers, and then we simplify. So since this is to the 4th power, that means I'm going to have 5 terms. So I'm going to write 5 blanks. And I'm going to do this vertically because I think some people can see it easier vertically, and we've been doing a lot of problems vertically. Now, since it's to the 4th power, I'm going to highlight these because these are the numbers that are going to work for this problem. Okay? And so those are the coefficients I write. So I have a 1, a 4, a 6, a 4, and a 1. So the next thing it says to do, it says write the first term of each coefficient left to right. So my first term is x. So I start with x to the 4th, x to the 3rd, x to the 2nd, x, and then no x. And then I go the other way with my second term, y. So y to the 4, 3, 2, 1. And now I'm able to put my answers together. 1 times x to the 4th is just x to the 4th. 4 times x to the 3rd times y to the 1 is just 4x to the 3rd y. 6 times x squared times y squared is 6x squared y squared. 4 times x y to the third is 4x y to the third. And 1 times y to the fourth is y to the fourth. Now the last thing I need to do is know signs. If you ever have a plus, they're all pluses. So if you ever have a plus to any power, all plus. If you ever have a negative to any power, it's minus, plus, and you continue that pattern. Okay, so what we're going to do now is we're going to try some problems. So we're going to expand. So what I'd like you to do is I'd like you to first figure out how many terms you need. Well, since this is to the third power, I should have 4 blanks. 1, 2, 3, 4. Now the second thing I do is I go to my triangle and I write the coefficients. And so my coefficients are 1, 3, 3, 1. The second thing I do is I go with my first variable. So that's x to the third, x to the second, x to the 1, no x. And then I go to my second term. And I start on the right. 4 to the third, 4 to the second, 4 to the 1. Okay, well now I can multiply going down. 1 times x to the third is just x to the third. 3 times x squared times 4, well that's 12x squared. 3 times x times 4 squared, well 4 squared is 16, and 16 times 3 is 48. With 1x, and then 1 times 4 to the third, 4 to the third is 64. Now, because I added, all of these are pluses. And there's my expanded form. Okay, let's try another one. Let's do x minus 5 to the fifth. So again, the first thing I need to do is I need to figure out how many terms I have. Well, I have 5 to the fifth power, so I need to have 6 terms. So 1, 2, 3, 4, 5, 6. The next thing I'm going to do is I'm going to go list my exponents. Now, what I'd like you guys to start recognizing is that the first one's 1, the second one's 5 because it's to the fifth power. Last one's 1, this one's 5. And so you at least know those. And now if I need to, I could go look, and then the other ones are 10. So I start with my first one, and I go down x5, x4, x3, x2, x1. And then my second one is a negative 5. Now, I'm not going to deal with the negatives because remember, if we have a minus, we're just going to rotate signs from negative, positive, negative, positive. So I'm just going to do 5. So it's 5 to the fifth, 5 to the fourth, 5 to the third, 5 squared, and 5 to the 1. And so now I need to multiply going down. 1 times x to the fifth is just x to the fifth. 5 times 5 to the 1 is 25. X to the fourth. 10 times 5 squared is 250. X to the third. 10 times 5 to the third is 1,250 x squared. 5 times 5 to the fourth, that's 3,125x. And then 5 to the fifth is also 3,125. And you can plug those in the calculator to get them. Okay, well, I have a minus, so it's minus, plus, minus, plus, minus. And there's your answer. Okay, so the last type that we're going to do is when you have them that have a term in the front and the back. So if I have something like 2x plus 3 to the fourth. Again, you start off by figuring out your number of terms, and since it's a 4, I'm going to have 5 blanks. My first term is 1, my last term is 1. My next one's 4, and this one's 4. And then if you don't remember, you can look up above on the pyramid, and it's 6. Okay, so now here's something we need to be careful with. My first term is 2x. So it's 2x to the 4th. I'm going to have to distribute that to both. 2x to the 3rd, 2x squared, 2x to the 1, and then no 2x. And then I have 3. So 3 to the 4th, 3 to the 3rd, 3, 2, 3, 1. And now I'm going to multiply down. 1 times 2 to the 4th is 16x to the 4th. 2 to the 3rd is 8. 8 times 4 is 32. Times 3 is 96. Pencil keeps breaking. So it's 96x to the 3rd. 2 squared is 4. Times 3 is 12. Well, actually, not even times 3, times 9. And then times 6. So it's 216x squared. 2 to the 1 is 2. Times 4 is 8. And 3 to the 3rd is 27. So that's 216x. And then 3 to the 4th is 81. Since it's plus, they're all plus. Okay, so the next type of problem you're going to have is if you have to find certain terms. Okay, so we have them listed here. And we'll just do a couple of them. Number 5 says the second term raised to the 7th. Okay, so my first term is 1. My second term has the coefficient of 7, right? Because the second term is that exponent. So this would be x to the 7th. So this would be x to the 6th. Now, if I go backwards, I can find my answer. But let's look at what we have here. Whenever I have exponents, I had 4 x's and 1 5, 3 x's and 2 5s, 2 x's and 3 5s, 1 x and 4 5s. If you notice, those exponents always add up to the exponent you have. They add up to the 5th. So if I have 6 of these, I know that I'm going to have 1 of my 6's. And so 7 times 6 is 42. And so that's my answer. All right, number 6, I should write this down so we can see what it is. The 9th term is the very last one. Well, on the last one, I know my powers, my coefficient's 1. And my second number is -4 to the 8th. Well, I don't know this one, or because I have 8 here, I won't have another one there. And so -4 to the 8th, it's an even power, so we know it'll be a positive number. I'm just looking for my calculator. Oops, that's not that. And so 4 to the 8th, let's go the other way. 4 to the power of 8. Oh, that's not right. And that's what we get. I can't get my calculator to work on this. Where's this thing? Oh, here we go. Let's clear this out. Y, 4y, 8. And so it's 65,536, and there's no x. So that's just the answer. Okay, let's look at number 7. The cat's meowing in the background. So 2x plus 3 to the 7th. This time it wants the third term. I know the first term's 1, the second term's 7. Okay, my issue is I don't know the third, so I'm going to look at the 7th row. The third one is 21. Okay, so this would be 2x to the 7, 2x to the 6th, so this is 2x to the 5th. Well, that means that this has to be 3 to the 2nd, because those, again, have to add up to 7. And so I need to figure out what 2 to the 5th is. So 2 to the 5th is 32 times 9 times 21. It's a pretty big number, 6,048 x to the 5th. All right, and then the last one, 4x minus 1 to the 8th. Again, we're wanting the 8th term, and so that's nice. It's the last one, so that's 1. I know I don't have any of these, but I'm going to have 8 negatives. Well, 8 negatives is just a positive, so this was nice because the answer is just a positive 1. So remember these steps. Determine the row, write the coefficients. The first variable is left to right, the second number is right to left. And then remember that your exponents here should always add up to your power that you're raising it to.